Mathematics Level 4, Topic 2, Module 4. Topic 2, Functions in Algebra, Module 4. Module 4, Session 1. Session 1 will cover the following content. Subject Outcome 2.4, Differentiation, Introduction. Differentiation, Learning Outcomes. Differentiation, Pre-Knowledge and Approach to Teaching. Learning Outcome 2.4.1, Establish derivatives from first principles. Subject Outcome 2.4, Differentiation, Introduction. In this module and the next, we are going to work on differentiation. Differentiation is under Subject Outcome 2.4 in the curriculum as instantaneous rate of change. This section is tested in Paper 1 of the end-of-year examination and makes up 25% of the marks for this paper. It is the largest section of Topic 2. Students begin studying calculus, including differentiation, in Level 3, so some of the learning outcomes will be revision. Before we begin, let's watch an introductory video on differentiation.
Hi, I'm Ivan McPalling. Let us do differentiation.
Differentiation, learning outcomes. In Level 3, students covered some of these topics. They should be familiar with the following: the intuitive concept of a limit, the derivative of basic functions by first principles, the derivative of some basic functions using differentiation rules, solving real-life problems involving maxima and minima. For Level 4, let's take a look at Subject Outcome 2.4 and its learning outcomes in more detail. You will find them on page 7 of your Level 4 Subject Guidelines. Subject Outcome 2.4 requires that students investigate and use instantaneous rate of change of a variable when interpreting models both in mathematical and real-life situations. By the end of the subject outcome, your students should be able to establish the derivatives of various functions from first principles, find the derivatives of various functions, use the constant sum and/or difference, product, quotient, and chain rules for differentiation. Find the equation of the tangent to a graph at a specific point. Solve practical problems involving rates of change. Draw graphs of cubic functions. Determine or prove maximum and minimum turning points by making use of second-order derivatives. Level 4 builds on the knowledge learned in Level 3. The following sections are new in Level 4. Differentiation of the cubic function, the reciprocal and the hyperbolic function from first principles. Applying differentiation rules to E and trig functions. The product, quotient, and chain rules. Finding the equations of tangents using differentiation. Rates of change problems. Drawing the cubic function. And using second-order derivatives when working with maxima and minima. Differentiation, pre-knowledge and approach to teaching. Please work in groups to do this activity. How do you teach differentiation in your college? What pre-knowledge is required? What problems do you experience? Where do your students struggle and how do you help them? Let's take a look at some of the pre-knowledge needed for differentiation. Students need an understanding of the exponent and surd laws from previous levels. They need to understand how to factorize third-degree polynomials using the factor theorem in order to sketch cubic functions. And they should understand the rules of differentiation learned in Level 3, that is, the first 3 basic rules and the sum and difference rules. Teaching tip. Students tend to misunderstand some aspects of differentiation, and they often don't understand all of the different notation used. It's often helpful to teach this section from scratch to iron out these problems. Learning Outcome 2.4.1. Establish derivatives from first principles. Students first encountered differentiation from first principles in Level 3. In Level 4, students need to apply first principles to find the derivative of some more complex functions, including the cubic function, as well as the reciprocal function and the hyperbolic function. Examiners like to ask questions on differentiation of these types of functions from first principles in the exams. Students often struggle with substituting correctly into these functions when using the first principles formula. They also find multiplying out of the binomial cube x plus h cubed particularly tricky. Students should be familiar with the concept of the derivative as an instantaneous rate of change from Level 3. Lecturers may need to revise this concept with students, so we will take a look at some revision of the theory. Let's consider a car travelling at a constant velocity. This can be represented by a straight line graph. The gradient of the line gives us the velocity of the car, which is the rate of change of displacement with respect to time. In this example, the rate of change is the same at any point on the graph. The gradient is constant. Now let's consider a car that is travelling at a changing velocity. The gradient again gives us the rate of change of displacement with respect to time, which in this case differs from point to point. We can see that the gradient or instantaneous rate of change at A is not the same as the gradient or instantaneous rate of change at B. This instantaneous rate of change of a function at point A is also called the derivative of f at A or f prime A. We can also say that the derivative is the gradient of the tangent to the curve at point A. Let us again consider a curve y equals f of x. We can see from the diagram that point A is at the intersection of x and f of x. When a small value delta x, meaning change in x, is added to x, B is the point at the intersection of x plus delta x and f of x plus delta x. We must note that the diagram has been magnified for clarity, but delta x is a very small value. The formula for the gradient of AB is the change in y divided by the change in x, or delta y over delta x. Looking at our graph, delta y can be substituted with f of x plus delta x minus f of x, which gives us this formula. Now if we move B closer and closer to A, delta x approaches 0, and AB becomes the tangent to f of x at point A. So to find the gradient of the tangent, we take the limit as delta x approaches 0 of our formula for the gradient of AB. This gives us the limit as delta x approaches 0 for f of x plus delta x minus f of x divided by delta x. When working with the formula for the gradient of a tangent to a curve, we replace delta x with h. So our equation for the gradient of the tangent to a curve becomes the limit as h approaches 0 for f of x plus h minus f of x divided by h. When we apply the formula for the gradient of the tangent to a function such as this, we call it differentiating from first principles. This formula is provided on the formula sheet for paper 1. Let's take a look at how a lecturer applies the formula to a basic example.
Differentiation from first principles. Differentiate from first principles given y is equal to 2x. Now when they say differentiate from first principles, which means that you must be familiar with the principle which says f prime x should be equal to f of x plus h minus f of x all over h. Now we must understand that this is, of course, with the limit as h approaches 0. In other words, they're saying differentiate this. I always suggest the following. When you have a problem to differentiate from first principles, use the normal differentiation to have your final answer, such that whatever you found as an answer here must match up with the derivative that you have found there. Let me explain what I mean. So we know that f of x is equal to 2x. This is this. That's what you are given. In normal differentiation, not first principles, not from first principles rather, would be f prime x. It would say, bring the power down and multiply. So this would say 1 times 2. This 2, bring the power down, which is 1. X, take 1 from the power. This normal 1 power minus 1, which then gives us 2 times 1 is 2. X to the power 0. We know that x to the power 0, anything to the power 0 rather, is equal to 1, which then becomes 2 times 1, which gives us 2. Here, ladies and gentlemen, we could have seen from here, that f prime x is equal to 2. End of the story. I just had to break it down for you. Which means that once you have differentiated from first principles, your final answer must be this. So it's always nice to guide yourself. It's always nice to use the short method of differentiation, so that when you get your final answer, it must go back to the answer which you found here using first principles. Now let's go differentiate using first principles. F prime x is equal to the limit of f of x plus h minus f of x, all divided by h. We are given that f of x is equal to 2x, so equals, as h approaches 0, that is very important. So equals the limit of f of x. So what is f of x? F of x is 2x plus h. This is f of x plus h minus f of x. F of x is 2x all over h as h approaches 0. What does it mean? It means the following now. Your limit will be 2 times x, 2x. 2 times h, 2h, minus 2x all over h. Okay? As h approaches 0. The limit, collect like terms, 2x minus 2x plus 2h all over h as h approaches 0. This cancels this, gives you the limit of 2h divided by h as h approaches 0, gives you, still, you do not substitute with h here. You do not substitute with h equals to 0, no. Why? Because you still have to sort out the denominator first. So you can see that h divided by h is 1. The limit still exists. So h divided by h is 1. 1 times 2 is 2. Then you substitute. Do you have h here? No. So, final answer, f prime x is equal to 2. Since there is no h in anywhere in this solution, the h, your limit of 2 as h approaches 0 disappears, because it's meaningless, it's useless. There is no h to substitute with. So your final answer, f prime x from first principles, is equal to 2. Does this answer correspond with the answer you found using the short method of differentiation? Yes. So your answer is correct. You have differentiated from first principles. Again, remember, from first principles, the first tip I would give you, differentiate using the short method to check your final answer. Once you've differentiated, of course, take into account the x plus h method, the f of x plus h method, minusing f of x. Always remember, divide by h. Do not use the h approach 0 limit. The limit can change, by the way. Your limit can also be saying as h approaches 2, as h approaches a certain value. But what does it mean? It means that the limit of this as h approaches 0, which means that h gets closer and closer and closer to 0, but it never equals to 0, because if your h equals to 0, which means that anything divisible by 0 is undefined, which means this function will collapse. For that reason, our limit here is, our limit of h here is 0. Your limit can change based on the nature of your function. But remember, you only substitute the value of h, which is h approaches 0, on your final step, after you have done all the eliminations and all the calculations. That is a general video on differentiate from first principles.
Differentiation of cubic functions and the reciprocal and hyperbolic functions are popular exam questions. Work through these two examples in groups. As you work through the activity, think about what problems students experience when doing calculations like these. Here are the solutions.
Use first principles to find the derivative of the function of x is equal to 2x cubed. What we need to know here is that if you look at your formula sheet, formula number 4, m is equal to the limit of where h is equal to 0, the function of x plus h minus the function of x over h. That is first principles. Now there are a variety of ways which people approach this, but to make marking easier, I suggest that we do it step by step. In other words, find each component inside that formula separately until you got the last and final answer. So I will write down there number 1, and then I will say it is given that the function of x is equal to 2x cubed. Then the very first step is to find the function of x plus h, because by doing this, you clearly explained to the learners that x is now replaced by x plus h. So it's 2, bracket, very important, keep the 3 there. You got no right to change questions here, because the learners normally just write x plus h, but then they forgot the 3. Or the learners somewhere make x3. No, whoa, no. X is replaced by x plus h, but the exponent 3 remains there. Now what is very important, you can either solve this by means of the binomial theorem, or I will suggest that you use the Pascal's triangle. In other words, you have 1, then you have 1, 2, 1, and then you have again 1. 1 plus 2, that gives you 3. 2 plus 1, that gives you 3, and then 1. In other words, we're going to focus on this one. That gives you the power 3. What does that mean? You're going to say 2, square bracket, x3 plus, because it's 1x3 plus 3. Remember, x is descending. If it's 3 there, then it will become there 2. H will be ascending, so it will start with 1. Plus, you can see there again 3. X, obviously, 3, 2, 1. And then H, 1, 2. Can you see it's ascending? Plus, obviously, 1 h to the power 3. Very, very important that you need to know that, and you can get that with the 8 of Pascal's triangle. And now you multiply the 2 out. 2x cubed plus 6x squared h plus 6x h squared plus 2h cubed. Your next step is you're going to say, okay, the function of x plus h minus the function of x. Obviously, the function of x plus h is all these 4 terms. So, 2x cubed plus 6x squared h plus 6x h squared plus 2h cubed. This is the function of x plus h minus, and then the function of x is given as 2x cubed. And what you're going to do now, you simplify your like terms, 2x cubed and minus 2x cubed. So you have x 6x squared h plus 6x h squared plus 2h cubed. And immediately in this step, you take out h as a common factor. Why? Because your next step is you're going to divide by h, then it's going to be much more simpler. 6x squared plus 6xh plus 2h squared. Let's just check your answer. 6x squared h plus 6xh squared plus 2h, 2 plus 1, 2h3. Your next step is you're going to divide by h. It's going to make it now very easy because you've simplified the 3 terms on top to 1 term where h is already isolated. You're going to get h 6x squared plus 6xh plus 2h squared over h. And what do you get there? You get an answer of 6x squared plus 6xh plus 2h squared. Let me just explain to you why I prefer making this one term. If you write those 3 terms over h, the tendency is normally you just divide h into the first term and you forgot about the others, which means you're making a principal error. And then your last formula will be the limit where h tends to 0, which means you will now substitute all h's with 0. And then you will get your final answer. 6x squared plus 6x, h is substituted by 0, plus 2h is substituted by 0 square. And you have a lovely final answer of 6x squared, which should be the derivative of that. Let's check. 3 times 2, it's 6. X, 3 minus 1, it's 2. And that is be your first answer. Now, your second question here is you just need to substitute because you have already calculated now the derivative. But the value of x is -3. So you need to substitute x with -3 and get your final answer. The first derivative is equal to that answer, 6x squared. What does that mean? That means the first derivative where x becomes -3, which means I just substitute x with -3, but I also square it, and 6 times 9, that is equal to 54. Use first principles to find the derivative of the function of x equals to 2 over x at x is equal to 2. Now it's important that we need to take note, we need to understand this question. We first need to find the derivative by means of first principles of 2 over x. And once we've got that answer, then only we substitute x with the value of 2. So let's first do the first part by means of first principle, find the derivative. We start, the function of x is equal to 2 over x. Then our very first step, the function of x plus h. What is happening here? X is now substituted with x plus h. Then now we're going to do the subtraction, the function of x plus h. People, this is procedural problems. So you just follow the recipe. The function of x plus h, that's 2 over x plus h, minus the function of x, which is 2 over x. What do we have here? The difference between two fractions with different denominators. In other words, if I can just highlight something here, it's a over b minus c over d. You can see here two different denominators at the bottom. You're going to have the product of those denominators, which means it's going to be x plus h. That's the product. And then your first term will be the product of those two, AD, minus your second term, it will be BC. Obviously, the product of those two, which is 2x minus, I always put my monomial in front, 2 times x plus h, and you close. Your next step is you remove the brackets and you simplify. 2x minus 2x, and a minus and a minus gives you a plus, sorry, a minus. Minus and a plus gives you a minus 2h, so minus 2, and a plus gives you minus 2h over x plus h. And what do you get there? Finally, you will get like term, 2x and a minus 2x cancel out. You have minus 2h over x plus h. Your next step, you will divide by h. Function of x plus h minus the function of x divided by h. When you divide by h, people, you times with 1 over h. X plus h, obviously, times 1 over h. And what do you get there? The h there and the h there cancel out. You'll have minus 2 over x bracket x plus h. Then your last step, the limit, where h tends to 0. What does that mean? Substitute all h's with 0 of x plus h minus the function of x over h, that is equal to minus 2 over x bracket x plus 0. And what do you get there as a final answer? That is equal to minus 2 over x times x. That is equal to x squared. Let's continue with this question on the other side. We have solved the limit, which means the derivative with the aid of first principles, and we got that. It means that the derivative with respect to x is equal to that value, minus 2 over x squared. Now they want us to find that value when x is equal to 2. In other words, it's going to be the derivative where x becomes 2 equals to minus 2 over bracket x becomes 2 and it must be squared, and that gives us a final answer of minus 1 over